Good day, everybody. How are you all? Hope you are doing great today. Together, we will work on this simple problem. For the three previous seasons, John has 20% of his 3 point shots during a basketball game. Hoping to improve this average, he diligently practices for 6 months. After this time, he notices that he sank 21 of his next 75 attempts at a 3 point shot. He does the appropriate significance test to find out whether the proportion of his shots has actually improved. Which of the following is the correct p value for this test? So let's move this maybe a little bit up. Okay. So after he practices diligently for 66 months, he noticed that he sank 21 of his next 75 attempts. So sample proportion of success, sample proportion of success now after 6 months, of training is p hat, which is number of success divided by sample size, and he sank 21 out of 75. And that will work out to, we'll use our calculator, 21 divided by 75, which is 0.28. So p hat is 0.28. Okay. Now, previously, he used to uh, be successful at only 20% of his shots, as given here. So, for the three previous seasons, John has 20% of his 3 point shots during a basketball. After practice, the sample proportion of success at 3 point shots is 0.28. Now he has to perform a hypothesis test to find out whether his uh, proportion of success has really improved. So basically, he has to do a test of hypothesis, which is 80. Okay. His proportion of success is greater than his previous record. This is the population proportion of success, 0.2, and his alternate will be, I'm sorry, I made a mistake, my mistake. So he wants to test whether he has improved. That will be the alternate greater than 0.20, because 20% was his proportion of success previously. Has he improved? So the null hypothesis is the status quo. That is, it has not changed. The sample p is the population proportion of success, and that has remained at previous value, which is 0.2. However, he has collected a sample. The sample proportion shows some improvement. Did he really improve? That is the question. That's why we are doing the hypothesis test. Is this population proportion of success now greater than 0.2? Can we come to that conclusion based on the sample proportion of success, which is 0.28? So basically, we have to calculate a test statistic z, test statistic, which is Z is equal to sample proportion minus the value in the null hypothesis is 0.2 divided by square root of uh, sampling distribution, or best by the divided by the standard error of the sampling distribution of p hat, which is p0. Remember, this is my p0, value in the null hypothesis, times 1 minus p0 over n. So p0 is the value in null hypothesis, in the null hypothesis. So maybe I should write this just as p0 instead of putting the value in the first place. So it should be p hat minus p0. Okay, and p hat is 0.28. So if I substitute the value of p hat and p0, etc., in the test statistic becomes, so please do not quit. I will give you an important tip at the end of this program. So if I move this a little bit up, so my test statistic now becomes Z is equal to p hat, which is 0.28 sample proportion, minus the value in the null hypothesis is 0.20, divided by, now this quantity I'll mention in a minute is 0.20 for p0, 1 minus p0 is 1 minus 0.20 divided by sample size of 75. The term in the denominator, this thing is the standard error of the sampling distribution of sampling distribution of p hat. Distribution of p hat. Okay. So let me move this a little bit up. I will draw you the standard normal curve. This is z is equal to 0. This is a right tail test. Remember, direction greater than means right tail test. This is your test statistic, and we want to find the value. We want to find out the probability of z greater than the test statistic. 0.28 minus 0.20 divided by square root of 0.20 times 1 minus 0.20 divided by 7.5. So this is the standard normal curve. Now, this is your p-value. So we want to find the p-value, and I will move this up a little bit. Find the p-value and compare p-value is the area to the right of the test statistic. Right of the test statistic. Z. If p-value less equal to alpha, then reject H0. On the other hand, if p greater than alpha, do not reject H0. Hence, the correct answer for this is part B. Okay. So this will reduce to the correct answer is B, choice B, which is P probability has to find the probability Z greater than 0. Oops, sorry. Greater than 0.28 minus 0.20 divided by 0.20 times 0.80 divided by 75. Not 7.5, it's 75. So I'll clarify the mistake here. That's your sample size. So correct answer is B. So I'll highlight this a little bit. B. Correct answer is B, as in boy. B. Okay. So if I move up, you will see the correct answer. Correct answer choice is B, as in boy. It's greater than because it's the right tail test. You're comparing to the value in the null hypothesis of 0.2. 0.28 is a sample proportion. And then you're dividing by the standard error of the sampling distribution. So the first thing we did was we to find out the sample proportion of success, which is X over N, which is 21 shots he sank out of 75, which is 0.28. Now you'll compare this sample proportion 0.28 to the value in the null hypothesis, which is 0.2, because he wants to find out whether he has improved, whether he's greater than 0.2 now. Since it is greater than in the alternate, it's a right tail test. And therefore, the test statistic is p hat minus p0 divided by square root of p0 times 1 minus p0 over n, which is 0.28 minus 0.20. You're comparing the sample proportion to the value in the null hypothesis, hypothesized value of 0.2. Divide that by the standard error of the sampling distribution, which is 0.2 times 0.8 divided by 75. Your correct choice is B, as in boy. I will stop here today. If you have any question or comment, write me a note. If you like this video, please give me a thumbs up. If you like this video, please write me a note saying that you really enjoyed this video. I appreciate that. If you did not like this video, give me a thumbs down. If you have any question, please write me a note. I'll immediately answer it. If you like this video, please give me a thumbs up. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button and let YouTube notify you when I upload a new video. So please do not forget to watch me tomorrow when I'll be back with another interesting problem, interesting solution. Thanks for watching. Have a nice day. Take care. See you later.